Welcome to the IPv6 Buzz, where we dare to dive into the 128-bit address space wormhole. I'm Ed Horley.
And I'm Nick Baraglio. We discuss everything IPv6 on the show, from strategy, design, deployment, operations, and even internet standards.
And I'm Tom Coffeen. We've spent 20 plus years working with the IPv6 protocol. We work on getting IPv6 working.
And we're here to share some lessons learned and how to avoid common mistakes. Well, hey, we're glad you joined us. We want to talk about an IPv6 Basics topic for this go around, and we want to cover dual stack because it's probably one of the more common questions that we get is, what is dual stack? When should you be using it, et cetera, et cetera. So we wanted to dive in and take an opportunity to do that today and just talk about, what sort of impacts dual stack may or may not have on your design and your philosophy and how you think about IPv6 in your network. So I guess we'll kick it off and say, start from the beginning. What is dual stack? What do we actually mean when we say dual stack? And how does that actually impact, how we think about IPv6, I guess, in general? So I don't know. I guess we can start with what maybe some RFC definitions. I think RFC 4241 is like one of the originals, OGs, that sort of talks about network environments that have V4 and V6. And basically what it is you're basically running both protocol stacks simultaneously. So, and that's going to be natively on a device or some sort of network infrastructure. So you have both V4 and V6. And that allows the device to communicate with either V4 or V6, depending on what that device decides it needs to do. So I guess that's partially dependent on DNS. It's partially dependent on what commands you actually execute on the end device to determine which protocol it's actually going to utilize. And I guess technically by that standard, if you have one interface, you have multiple interfaces on a host, and one interface is talking IPv4 and the other interface is only talking IPv6, that fits in the dual stack category. Even though I think more commonly we think of it as a single network interface that has both V4 and V6 as protocols running simultaneously on that same interface. I don't know, Nick, if that's probably more of a common thought in terms of how you think about dual stack.
Yeah, I think most people assume that it's the single interface and it's running two protocols on it, but there's no, to me, I mean, I've actually done it that way before where I've had an interface I have a NAS that runs this way now. It has IPv6 only on one interface and IPv4 only on the other. I can't even remember why I did it. I think it was probably so that I could easily see which one was using more. It just never really was a problem. So, they're independent protocols. And I think that's a really important point that may or may not be, I mean, to me, it feels obvious, but it may not to other people, is that, these are completely independent of each other. They're ships in the night. They can run on separate interfaces and do all the things they need to do as long as those interfaces get them to where they need to go. But I think for the most part, if you ask somebody, random person on the street, what does dual stack mean? They're going to go, what are you talking about? But if you find like Tom's on assignment right now, and he could be out on the streets asking people, and if someone were to respond, they might say, well, it's when you have IPv4 and IPv6 on the same host. And when they say host, I think they really mean interface.
Right. Yeah, I would agree with you on that one. And there are certain sets of transition technologies that sort of probably are a little bit dependent on which deployment model you're actually doing. And so this is sort of holds true for some networking devices and things of that nature. The reality is I don't think it impacts performance or design in any one way in particular, but it might impact just how you do your deployment. So if you're doing a server load balancer, you might actually have two separate interfaces, one doing V4, one doing V6, versus a singular interface that's doing both. There's no reason that you can't do both, by the way. So you could have multiple interfaces that are all doing both, or multiple interfaces that are, some are doing V4, some are doing V6. I think by having multiple interfaces that each individually do one particular protocol, you might be introducing some complexity in terms of understanding maybe the routing tables and where things are forwarding. Singular interface, maybe a little bit easier in terms of understanding what's going on, at least for an end client device, maybe not for, a server load balancer or some sort of more sophisticated network device like a firewall. You might intentionally choose to run those separately for very specific reasons. So I would say that would be my first sort of, foray into sort of defining what dual stack actually is, which means you're just running both protocols so that the host can have both v4 and v6. And I don't know if we really care which interface they're doing it on, or if they're doing it on the same interface. I don't think that really matters. And then by doing that, you're basically leaving it up to the client to decide what's going to happen. I think that's an important distinction, right? It's not a network decision in terms of what's going on. The client decides about which protocol it's going to utilize, which is definitely a little different than maybe traditionally how we've always thought about v4 and maybe networks having a little bit more explicit control over that stuff. Now the client side device is determining either via happy eyeballs or via DNS records which protocol to actually use. So that's definitely something new and different in terms of dual stack and the impact of dual stack. I guess the next natural question is, in the life cycle of adoption, in the great overcoming barrier of adopting v6, where does dual stack fit in the overall sort of curve of your v4 only on the far left to v6 only on the far right? What does that mean, and where does this fit, and is it just dead in the middle, or do we think about dual stack differently today given the options that we have? So what's your feeling on that one, Nick? Where does dual stack fit in the overall adoption play?
I mean, I've always considered dual stack to be the transition period between the two. That can be, that transition period, clearly it's a long time, right? I mean, dual stack has been around for what, 15? I mean, a long time, 20 years.
Yeah.
It's the period when you have to do both because it's too hard to only do one. And I think that it's reaching the end of its very long tail right now. This is my opinion, right? Because we now have CLAT available on pretty much every major platform, or it's, imminent on every major platform. And what CLAT gives you is the ability to, with a PLAT, with a NAT64 somewhere in your available range, doesn't have to even be on your direct path. With that, it allows a host to run with only IPv6 and still gives it the capability to speak to the legacy addressing, right? Because it does the translation locally, and spits everything out to the PLAT, and it handles the protocol, the actual protocol translation. So I think that now that is really imminent, or already here in most cases, I think that dual stack is going to hopefully begin that decline. I mean, if you look at mobile networks, they've been this way for a very long time, right? And we rely on them for everything. I mean, they are critical, the literal definition of critical infrastructure. So if they can do it, why can't anyone else?
Yeah,
right?
Any enterprise network, home network, et cetera.
Yeah.
I would agree with you. I guess the caveat being that if you're an organization and you run a data center and you need to support these transition technologies, in other words, you need to actually operate the PLAT for the CLATs to connect to, you need to operate the NAT64. You're going to be running a service block architecture in your data center that is dual stack. Those devices need to be able to talk both protocols because they need to be able to basically stitch those two networks together on your behalf. And I imagine you want some semblance of control and security and other things to wrap around it. So, in terms of the life cycle of adoption, I would say as long as you need v4 available within your network in some capacity, you're going to be running dual stack, at least in a portion of your network, to basically handle these transition mechanisms. And that's not a bad thing. I mean, dual stack, I think, will be here for a very long time. I think the difference primarily being is on the client side. In the past, we considered having dual stack pretty much everywhere where a client device would be made available. I think with the options of IPv6 mostly today, as you mentioned, we can move away from that, and we can basically be v6 only at the client side edge, and really reduce the footprint of how much IPv4 we have in our overall network landscape by basically leveraging that CLAT to solve that particular problem, and in a very distributed way, which is nice. scalable and distributed are nice pluses as a side effect of what's going on there.
I would also argue that it's an exercise in risk mitigation and risk minimization, right? So if you're thinking, I'm putting my enterprise network engineer hat, am I skeptical? Why do I need IPv6 hat person on? And if you look at it from the point of view of, if I'm going to run dual stack, then I need to take into account securing both protocols. You need to do your due diligence, and let's be honest, there's a lot of network engineers that didn't live through, the things of running multiple protocols on the same hosts. They're too young to have done AppleTalk and IPX and DECnet and SNA and all of those things that us old guys had to deal with and learn how to turn off later. And so it's a new thing, right? And that's okay, right? But you have to understand that, like, now that risk zone of running the dual stack is significantly, you shrink it significantly when you create that service block architecture where you only have it in this location to do the transition between the two, right? It simplifies operational complexity, it simplifies overhead of management, and it simplifies complexity of configuration across the board when you're able to do that.
And troubleshooting. So troubleshooting becomes much easier in terms of understanding what your packet flow actually is.
Yep.
Yeah,
and IPv6 mostly really is I think that is the tool that we've been waiting for to do those things.
Yeah, I would agree. And it's already proven to scale out. IPv6 mostly sounds like a new thing, except for the reality is the mobile market has been effectively doing exactly that for decades, and really leveraging sort of the capabilities of what the mobile providers have proven out in the enterprise is really what's going on right now. And so we're getting the advantage of basically all the research development work and operational proof out along with troubleshooting of what you can really solve from a scale out basis with CLAT. And so I think that's an interesting point. So dual stack is still going to exist in your network. It's still going to be something that you have to implement. It's just, I think it's going to have a smaller footprint than what we would have traditionally done in the past. So a decade ago, if we told you to dual stack your network, it would have been everywhere. You may only be dual stacking smaller and smaller segments of your network. And I guess technically IPv6 mostly is a dual stack implementation because you can support v4 on the same network segment as what's going on. But the reality is you're really trying to run that as a v6 only network. And hopefully the end client is honoring that DHCP option to basically understand that it should be turning off v4 and doing that on a regular basis. So that's really, I think, the critical difference. So I guess in terms of lifecycle, we're really seeing dual stack migrating to IPv6 mostly, I guess, is how I would think of it.
That's exactly how I think of it.
Okay.
It's the next evolution. I've always said that IPv6 mostly, ever since I saw it, I said this will allow your network and your hosts to operate the highest level of their evolution. Right. If they can run IPv6 only, which, that's the current the current internet protocol. If they can run with that, they'll just do it. If they can't, they fall back to whatever is available. It's sort of it's the one ring to rule them all, or whatever you want to say, right? It can do all the things with the goal of doing only the most modern thing. And I would also, add that, some of the statements that I've seen is, why do I need to do this when I have a NAT box and all these other things? And you significantly simplify the troubleshooting process when you don't need to look at a state table or a NAT translation, or especially, a port, NAT PT, which is what everybody uses, right? Masquerading, where you have to look at what the port is and the source of the dest and all these things. Unless you just love doing those things, which some people might love doing that, you don't have to do that like nearly as much. And when you do, the protocol, it's IPv4, that your device is very likely going to keep a record of what those translations are. You can reverse engineer the addressing. It's a very simple algorithm to map a v4 to a v6 address. There's tools out there to do it. And as IPv6 kicks up from a resource perspective, which we've already clearly seen over the last 5 years as a really nice ramp, you don't need to do that. The amount of translation that you'll see will go down significantly, right? Because most things are going to be v6 out on the internet at this point. The content's already there. I mean, there are obviously things that aren't GitHub. Everybody says GitHub, right? So like there's things that aren't going to be there, but like I would say the vast majority, 80% of normal internet traffic could easily just be IPv6 if it was enabled everywhere, and maybe even higher.
Right. Well, I guess moving from the lifecycle question to are there advantages from a dual stack perspective? What's the advantages of actually using dual stack versus maybe an IPv6 mostly or IPv6 only, or obviously IPv4 only? Where do we see the advantage of using dual stack? And I guess my first initial response to that is, well, if you want to talk to both protocols, you have to dual stack. So that's your advantage, is that you can suddenly use transition mechanisms to bridge your two networks together to allow them to communicate. And then that gives you the capability to support both networking protocols within your environment. And it gives you the capabilities to do translation between both. That would be my first sort of initial fast response. And I think one of the advantages with dual stack, at least from maybe in your data centers, and is making services available on both, means that you can move traffic from v4 to v6 in a measured way, right?
Yeah, that was always the pitch that I would make is you can just run both. You have the advantage of being able to understand how they both work. You can troubleshoot both of them at the same time. It sort of forces you to do your due diligence on creating policies for both because they're both running. All the things that you kind of need to do to bootstrap. It was a bootstrapping mechanism, in my opinion, right? It was a good idea. It worked fairly well. The one downside was also its biggest upside, in my opinion, right? The biggest upside is that especially when happy eyeballs became a thing, if v6 did not work, it would just silently fail over to v4. The user was none the wiser, and everything just worked. That was its biggest advantage, especially with happy eyeballs, right? Because if one didn't work, it just used the other,
right?
And it was very fast. The downside to that is it painted over all the rust, so you never got to see, what
the actual structural deficiencies were.
Exactly. That is a much more. I was going to be way more crude when I described it, but that's a great way to describe it. You never got to see where the deficiencies were because the network took up the slack of hiding them from you. And when we started doing v6 only, and there was no CLAT on any major platform outside of mobile, oh boy. That's how we figured out all these problems that we're now addressing in standards is what happens when we turn this off? Because we have to turn it off. And oh boy, we turned it off. And now what the heck is happening? Let's go figure out all these little annoyances that popped right up because they are no longer hidden. Now, on one hand, you could say that CLAT kind of does that again. However, I think that because we had the last 5 years of going through the pain of trying to figure out what all those things were, those of us that were early adopters to v6 only have I would, let me, dislocate my shoulder, pat myself on the back here, but I think we've done a good job of finding a lot of that stuff and documenting it, talking about it ad nauseum, so that other people did not have to taste that pain.
Yeah, I guess part of the point with the CLAT journey is that at least the principal difference from happy eyeballs is probably the extensibility of logging the additional information that you can get, and the fact that it is in a fixed location within the application stack from the OSI model standpoint, right? It's it's in one location versus happy eyeballs could be in the application stack for a browser. It could be in the operating system. It could be separate implementations done with different algorithms and in different locations within your networking stack, and you don't necessarily know what's going on. And I think the CLAT is a very fixed function, which is nice. So from a troubleshooting perspective, it's a little easier. So I would say those are some of the advantages from a dual stack basis, right? Of where you can get, I guess. I guess let's talk about the disadvantages. Are there disadvantages around dual stack? And I guess the biggest one is operational overhead and complexity and security footprint, right? Those are the disadvantages because you're now exposed for both V4 and V6 for every single exploit. For, you can use V6 to try and, come in on a security basis and exploit and then turn around and send traffic out V4. Like there's all sorts of combinations of things that sort of, maybe make things more difficult to determine. Happy eyeballs obviously is another one because, you could be having, a single browser open up multiple sessions that are all connecting to different resources and stitching together and presenting you a single web page, but it could be going across a wild combination of V4, V6, server side, client side behavior combinations that you really struggle to sort of figure out how exactly this page is being built and delivered. And from an application developer standpoint, that could be very frustrating to really understand what's going on. So that could be a distinct disadvantage of that versus a singular protocol that really gives you the capability to understand exactly what's happening and what's going on. Even if you're using transition mechanisms, it's still easier with a single protocol than it is with two. And so I would say those are the distinct disadvantages of dual stack. I don't know if you can think of any additional ones, Nick.
Yeah, so those are the big ones, and I would double down, I think, on the application. Because that's not something, I'm not a developer, so I don't think about those things. But like, working in the V6 Ops working group, there are a number of very high level application developers in there, and they have essentially mirrored exactly what you just said, right? It's much easier to just deal with one protocol for so many reasons, not just complexity of code, although I'm sure that is a huge one too, but also in power savings and network activity savings, where you may be on a low speed or a cellular link or an RF link of some kind or a SATCOM link or something like that, where there just isn't the resources don't exist. So you want to minimize the amount of things that need to be open on the network and talking on the network. So I think that the application development piece of that for a single protocol is significantly easier. And I think a lot of times you can get around that. Again, not a developer, so maybe this is ridiculous to say, but you may be able to get around that by just saying, I'm going to rely on the operating system to tell me what network stack it uses, and not have to code any of that stuff in unless you're writing network applications, obviously. But the biggest one that's one that I think is pretty significant. There's also the security policy one, and where that can be particularly diabolical is if you have aging security appliances that may not have the same level of support for one protocol over the other. Maybe they have it, but it's more limited, or maybe one's done in hardware and one's done in software. I think that's less of a problem now if your gear is modern. But let's be honest, there are places that don't have modern stuff. They don't have budget to replace it. And it's, that's something you have to consider too, is are the devices in the path doing both protocols in the same way? And do they have roughly analogous support across them? Because obviously it's a different protocol. So you're not going to get one-to-one support because there's no ARP in V6. There's no,
Yeah.
So those are, I think, things that are definitely, I would consider those, I don't know if I'd say downsides, but they're definitely things that you have to really put thought into that you wouldn't have to if you're not going to dual stack.
Yeah, it's an additional burden, which I guess is a disadvantage in some ways, right?
Yeah.
Well, I think I'm really interested in hearing what the audience has to say about dual stack and where things fit for them and how they think about it. So we'd love feedback on it. So feel free, packetpushers.net/FU for the follow-up. And we'd love to be able to hear how you guys think about dual stack and if it's different in terms of, really how your understanding of the singular protocol, probably IPv4, is working today for you. And if you really see it different than maybe some of the transition methods. And if you're more excited about IPv6 mostly, I think we'll probably do an episode on talking through that in more detail, but definitely love to hear more about what you're thinking about it. Any final thoughts, Nick, on dual stack, or do you think we covered it all?
IPv6 mostly. This is the way.
Don't do dual stack. You'll have to do dual stack in part of your network, but at least client side, definitely look at mostly.
Yep. Agreed.
Cool. Thanks, everyone.
Thanks
for joining us for this episode of IPv6 Buzz. If you've got feedback or follow-up on this topic, send us a message at packetpushers.net/FU, where FU stands for follow-up. We'd love to hear from you and continue the conversation.
Also, at packetpushers.net, you'll find a range of other deep dive technical podcasts for IT pros.
There's a whole lot more on the Packet Pushers site as well, such as tutorial videos and a community Slack channel where you can talk with industry peers and experts. So whether you're deep in your career or just starting up, Packet Pushers is the place to go to grow both your skills and your personal network.
So long, and until next time, we'll see you on the IPv6 internet.